So class, there were two examples that I wanted to show you, but actually the first example, we talked about an example like this at the beginning of the class, where you have a Cartesian coordinate and you want polar coordinates, and you have two situations, one where r is greater than 0 and r is less than 0. So for that one, you have to draw a picture. Okay, you have to draw a picture. And I'm just going to, well, how many of you would like to, you want to work this one out? You want to work this one out? Who wants to work this one out? Okay, let's go ahead and work it out. I'll give you a moment to copy this down. Okay, so we have Cartesian coordinates 1, -3. So Cartesian coordinates, of course, mean XY coordinates, right? So this is X, this is Y. And we want to find out polar coordinates when r is greater than 0 and theta is restricted to be between 0 and 2 pi, and then another polar coordinate when r is negative and theta is restricted to be between 0 and 2 pi. So what we have to do is draw a picture. So here's my picture. And there's a lot of detail in the picture. I'm going to just give you a moment to copy it down. Again, we did a problem like this earlier today, but I just, want to have it like formally in your notes, and it'll be recorded too. So copy the picture down. What I do, of course, is I have the point 1, -3. That's down here. And the radius, if I want the polar coordinate, so since we have a 1 and a -3 as the legs, the radius is √10. So that's no problem. And the angle here, we can think of this angle, we can treat, I mean, you can think of it, okay, it's a negative angle. It's the arctangent of -3/1. And the arctangent of -3/1 is going to give you a negative angle. Okay. Now, before we treated that angle, and I'm talking, we had a different example, but we treated this angle, we just sort of said to ourselves, well, that angle, if we don't worry about it being a negative angle, what would the magnitude of that angle be? And we said we would say the arctangent of 3/1. But you do it the way you want to do it, whatever works for you. If you wanted to treat it like a negative angle, you'd have the arctangent of -3/1. That would be your angle. And that angle is a negative angle. That angle is equal to, let me see, the arctangent of -3/1 is about -71 degrees, according to my calculator. Okay. You have to be careful when you put your calculator in degree mode. You've got to change it back then, right, to radian mode a lot of times, right? So, okay. So the theta that I need, if we want theta to be between 0 and 2 pi, this is the theta that I need right here. That's theta. So just take 2 pi well, you can take 2 pi and add your negative angle, the arctangent of -3, or you can take 2 pi and subtract the arctangent of +3. Okay, and that'll get you your theta. So that's the answer for A. Please let me know if you have any questions. All right, now for part B, we want a negative radius. So if we look in this direction here, but go backwards √10, that'll get us to this point. So that means the radius, of course, is -√10, but what is this angle here? What is this angle? Well, that angle would be this angle here. Okay, this angle here is the same as the angle opposite. So the green angle, I want to say this the right way, this angle here is going to be pi plus or pi minus the arctangent of 3. And so the second polar coordinate has radius -10, and angle pi minus the arctangent of 3. Okay. The problems are always easier to do when the angles are ones that you know, like 30 degrees, 45 degrees, 60 degrees, that kind of thing. But really what we're doing here is the same thing you do with those angles. It's just it's a little more interesting because you have an angle that's not like one of the angles that you're accustomed to. But nevertheless, we can do the problem. Are there any questions before I move to the second example that I wanted to do here? This is section H.1. All right, let's go to the second example. Here, we want to sketch the curve with polar equation r equals cosine of 2 theta. Let me give you a moment to copy the example down. Okay, now this problem here, we're going to do this in a little different way than using Desmos. Because I know in section H.1 there's a problem where they give you a graph of a function of theta, and based on the graph you have to draw the polar curve. So for this one, what I'm going to do is I'm going to graph cosine of 2 theta like we would a normal trig function. Like if y were equal to cosine of 2 theta, you know, you'd have an x and a y axis and we graph that trig function. Well, in this case, our horizontal axis is going to be theta axis, and the vertical axis is going to be an r axis. And so here in the problem, you notice we have an r vertical axis and we have a theta horizontal axis. And I've graphed the r equals the cosine of 2 theta. So I know you have a problem like this in your homework in H.1. And I think in that problem, they don't even give you the equation of the polar graph. They just draw it. And based on the polar graph, or based on the function, you have to be able to construct the polar graph. And so this problem is to help you with that kind of problem, which you could see on the final exam as well. It's important because, you know, making this connection between the trigonometric graphs and the polar graphs is important. It's an important connection to make. So keep in mind the period of a cosine function is 2 pi, but we have the cosine of 2 theta. So to get the period, you take 2 pi and divide it by 2, and that gets you pi. That's the period of this trig function. So what I do is I graph the trig function from 0 to pi, and I'm going to put in some nice angles. So, oh man, you know, pi over 8. Why is that a nice angle? Well, if you have the cosine of 2 times pi over 8, that equals the cosine of pi over 4, which is root 2 over 2, or about, let me see, root 2 over 2, I think that's about 1.4. No, I'm sorry, way off, 0.707, okay. See, I mean, you know, I get kind of rusty if you don't use it, right? Okay, so you see pi over 8 is a nice value. If you have the cosine of 2 times pi over 4, well, that equals the cosine of pi over 2, which is cosine of 90 degrees. That equals 0. So, you know, these are nice values. Now, 3 pi over 8 is also a nice value. If you have the cosine of 2 times 3 pi over 8, that's a cosine of 3 pi over 4. And that's just equal to negative root 2 over 2, which is about negative 0.7. So now what we're going to do, you see, is we're going to, let's look at this first point here. No, not that one. Point A. Actually, hold on. So when theta equals 0, the radius is 1. Look on the graph, the polar graph. when theta equals 0, the radius is 1. So A has polar coordinates 1, 0. For B here, the second point, maybe I'll put that in green. That's when theta equals pi over 8. Okay, so pi over 8 is about 22.5 degrees. So if we look at this angle here, this angle is roughly 22.5 degrees. I keep getting this. Hold on, get off there. 22.5 degrees. And this point B here, this point B, the polar coordinate on that is going to be root 2 over 2, comma, pi over 8. Okay, so far so good. Let me know if you have any questions. All right, for C, when you're looking in the direction of 45 degrees, the radius is 0. So that's C. And so you see what we're doing is we're tracing out, as we trace out the function, we trace out the polar graph. Let's do one more here, a couple more. When theta is equal to 67.5 degrees, okay, the radius is negative root 2 over 2, right? We computed that right here. It equals negative root 2. See, I'm running, I kind of want to, hold on. Yeah, negative root 2 over 2, which is about negative 0.7. So if we look in the direction, of 3 pi over 8, or 67.5 degrees, and move backwards negative root 2 over 2, that gets us to D. So D is negative root 2 over 2, 3 pi over 8. And if you look in the direction of 90 degrees and move backwards 1, you end up at this point here. This is negative 1 pi over 2. See, those are there's another polar coordinate. So you see how this works? And if you just keep tracing out the graph, okay, if you keep tracing out the graph, that's going to get you to here. But if you want to get the full picture, you got to go out another cycle of this cosine of 2 theta. And if you do another cycle, and where you were to graph the points, this would be, well, that would be your graph. You get a 4-leaf rose. If you graph r equals cosine of 2 theta in Desmos, this is r equals cosine of 2 theta. If you graph that polar graph in Desmos, you're going to get this 4-leaf rows. And now you understand from, it's one thing to just graph something in Desmos and there it is, but you should have an intuitive understanding of, you should be able to make the connection between the trigonometric graph that you learned, like in Math 98, and the polar graph. How many think this is absolutely cool? This this connection. Taj is liking it. Anybody else? I hope we might have a few more people. Okay, Ange is liking it. I can tell you, class, excellent, that when I was taking calculus and learned polar graphs, this is how we had to graph our polar curves. This is how we had to graph the polar curves, because we didn't have any technology to help us. We had to actually draw the trig functions, so you had to know trigonometry real well, and then based off of that, you could draw the polar curve and get the 4-leaf rows or whatever you needed to get. Obviously, the graphs couldn't be too complicated, right? But I remember in calculus too, I had a problem where I had to, I had to get the 4-leaf rows, and I remember doing this. So, all right, are there any questions before we end this recording? Okay, I'm going to stop there then. Excellent. So now section H.1, you've had a full set of examples. Excellent.